So this is just part 2 of section 7.2. I'll just lead in with problem 22. In problem 22, the left-hand side is 1 over 2 to the first power, all to the x minus 3. The right-hand side is 32, and the prime factoring for 32 is 2 to the fifth power. I'm going to write any fraction with a negative exponent, any non-prime number with its prime factoring. The left-hand side I'm going to write as 2 to the negative 1, and then parentheses x minus 3. And the right-hand side I have 2 to the fifth. I'm going to clear the parentheses on the left-hand side by multiplying negative 1 times x and negative 1 times negative 3. So on the left-hand side, negative 1 times x is negative 1x. Negative 1 times negative 3 is positive 3. Now I've gotten rid of the parentheses, I've gotten rid of the fractions, and both sides have the same base. Once I get that to be the case, I drop the bases and set the exponents equal to each other, and then do the algebra to isolate the x. Here I'm going to minus 3 from both sides, and give me minus 1x equals to 2, and then divide by negative 1, and gives me x equal to negative 2. Believe that's the answer. The original problem was 1/2 to the x minus 3 equals to 32. If I want to check, it should be the case that 1/2 to the negative 2 minus 3 equals 32. Super easy to do that. So let me just go parentheses, fraction, 1/2, parentheses exponent, negative 2 minus 3. This gives me 32 equals to 32. I might stop checking because it takes time that you might not want to watch. On 23 and 24, the denominators of the fractions are prime numbers, so I don't need to do prime factor trees for them, but I need to make the fractions into negative exponents. And in 24, the 9 is 3 squared. So I'm going to do prime factor trees for any number that's not prime. I'm going to make negative exponents out of fractions. Multiply the exponents to clear the parentheses. So in 24, negative 1 times x, which is negative 1x. Negative 1 times negative 4, which is positive 4. I should be able to do enough algebra to get both sides written with the same base. Once I get both sides written with the same base, I drop the bases and set the exponents equal to each other, and then do the algebra to solve for x. In problem 24, that's going to be minusing 4, then dividing by negative 1. When I minus 4, I get negative 1x equals to negative 2. When I divide by negative 1, I'll get my answer. And my answer for problem 24 is going to be 2. '23 should work similarly. Maybe we could do 25 together. So in 25, 4 isn't, it has a prime factoring tree. The prime factoring for 4 is 2 squared. So if I'm doing 25, any number that's not prime, I'm going to do a prime factor tree for. Even though there might be alternate ways to do the problem, that's the way I'm choosing. And the 256 is 2 to the 8th. So I start off doing a prime factor tree for any number that's not prime. If I have a fraction, I'm going to turn the fraction into a negative exponent. So on the left-hand side, I get 2 to the negative 2 power. And then I'm going to clear the parentheses on the left-hand side by going negative 2 times x and negative 2 times negative 7. Now that I have both sides written with the same base, I set the exponents equal to each other and I drop the base. And then do the algebra to solve for the x. In this case, in problem 25, I'm going to minus 14 and get negative 2x equals negative 6, and then divide by negative 2. Should never write down a wrong answer to one of these because they're pathetically easy to check if you have the right technology. So if I wanted to check this, I'd see if plugging 3 in on the left-hand side, I go parentheses, fraction 1 over 4, parentheses, exponent, and then 3 minus 7. When I hit equals, I should get 256, and I do, so it works perfectly. 27 should work similarly. I'll let you do it. It might have a fraction answer. 28, the left-hand side, 2 to the x, I don't do anything with it because 2 is not a prime number. The right-hand side, 16 to the x minus 4, I need a prime factoring for 16, which is 2 to the 4th. I put it inside of parentheses because it already has an exponent and I need to multiply the exponents. On the right-hand side, I need to go 4 times x, which is 4x, 4 times minus 4, which is minus 16. I still have the 2 in the base. So I should have 2 to the x equals 2 to the 4x minus 16. Both sides have 2's for the base, so I drop the bases and set the exponents equal to each other, which is going to be x equals to 4x minus 16. The x on the left-hand side is really 1x. And to get this solved for, I'm going to minus 4x from both sides, which will give me minus 3x equals to minus 16. Oh my gosh. And then I'm going to divide by minus 16. I'm going to check this because it's such a bizarre answer. I'm going to divide by minus 3. Duh. Divide by minus 3, divide by minus 3. On the left-hand side, when I divide by minus 3, I get the x. On the right-hand side, the two negatives become positive, and I get 16 over 3. I believe that's my answer, but it surprises me when I get fraction answers. So the original problem in 28 has x's on both sides. So I need to separately plug in the number on both sides. I need to see if 2 to the 16 over 3 power equals 16 to the 16 over 3 minus 4 power. I have no idea. So let me do the left-hand side. 2 exponent fraction 16 over 3. And it gives me, I'm just going to write a few decimals, 40.3174. I'm going to do the right-hand side, 16 exponent fraction 16 over 3 minus 4. And I get the same 40.3174. So my answer is right. Usually I don't make the answers fractions, but they can happen. 28 really isn't like 27. 25 and 27 are more alike. On the next page, we'll start running into these problems again. So you should be able to do 29 and 31. I'll do 30 and 32. On 30, the left-hand side, the 5's prime. I don't need to do anything to it. The right-hand side, the 26 isn't prime, so I need to do a prime factoring, put it in a parentheses because it already has an exponent. The prime factoring for 25 is 5 squared. The parentheses that I impose on the right-hand side, I'm going to clear by multiplying the exponents. I should be able to get both sides written with the same base. When I do that, I can drop the bases and set the exponents equal to each other. In problem 30, the x on the left side really has a 1 in front of it, which might help to write when I do the algebra to isolate the x. The algebra to isolate the x is just minusing 2x, which would give me minus 1x equals to 12, and then dividing by negative 1. That feels like a better answer. So for 30, without checking, I'm going to say the answer is x equal to negative 12. I'll do 31 with you, just because I can, and that way you can make sure you're right without having to check your answer on the computer. So for 31, left-hand side I'm not going to touch because 2 is a prime number. Right-hand side I am going to touch because 16 is not a prime number. 16 is 2 to the 4th. Because the 16 already had an exponent, I put it in a parentheses. On the left-hand side, I'm going to write a 1 in front of that x because it helps me with the algebra. Clear the parentheses on the right-hand side by multiplying 4 by 2x and 4 by minus 3. Now that I have both sides written with the same base, I drop the bases and set the exponents equal to each other. And if I get an ugly answer, I'm going to check it. Do the algebra to isolate the x. When I have 1x plus 4 equal to 8x minus 12, I'm going to get the x's on the left-hand side by minusing 8x from both sides, which will give me minus 7x plus 4 equals to minus 12. I'm going to minus 4 from both sides to get the number 4 on the opposite side. That's going to give me minus 7x equals to minus 16. Both the numbers are negative on the right-hand side, so I add them to combine them. And then divide by negative 7, divide by negative 7. I think, if I haven't made a mistake, the answer is 16 over 7. I should definitely check anytime I get a fraction because I don't like to make fraction answers. The original problem is 2 to the x plus 4 equals 16 to the 2x minus 3. I should see if 2 to the 16 over 7 plus 4 equals 16 to the 2 times 16 over 7 minus 3 power. No way I'd want to do that without a calculator. But left-hand side, 2 exponent fraction, 16 over 7 plus 4. My left-hand side comes out to, I'll just write a couple decimals, 78.01687. And then the right-hand side, 16 exponent 2 times fraction 16 over 7 out of the denominator minus 3. And I get that same 78.01687. So I know my answer is correct. There really isn't anything new. It's just a handful more problems to just push through. You might be able to just finish this without watching the rest of the video. I'll just do a handful of more problems. I don't know. I'll do 34 here, so it's because it's here. I get 7 to the 1x minus 1, and then equals 49 to the x minus 4. 49, the prime factoring is 7 squared. Because it already had a exponent, I put it in a parentheses. To clear the parentheses that I just imposed, I'm going to multiply the 2 by the x and the 2 by the minus 4. Once I get both sides written with the same base, I drop the bases and set the exponents equal to each other. And then I do the algebra to get the x isolated. Not really talking it, I'm just doing it. So you can watch that or just kind of mush through the problems that you need to work on. I'll do 35 with you just in case you're needing the help. I'm going to do the prime factorings in my head. For 35, the 27 to the x equals 9 to the x plus 1. 27 is 3 cubed. 9 is 3 squared. So since both the bases weren't prime, I'm doing the prime factor trees for 27 and 9. Because both sides already had exponents, I put parentheses on both sides. The left-hand side, I'm going to multiply to clear the parentheses. The right-hand side, I'm going to multiply the 2 by the x and the 2 by 1 to clear the parentheses. Once I get the bases to be the same, I drop the bases and set the exponents equal to each other, and then do the algebra to solve for the x. If I get a funky answer, I'll check it. If I get a nice answer, I'm assuming I didn't make a math error. So nothing really new on these. Maybe I'll do 39 and let you do 37, and I'll let you do 41. I don't think I need to do every one of these. So to finish up the video, I'm just going to do 39. And it needs 625, which is 5 to the 4th, and 25, which is 5 squared. So if I was doing 39, the 625 to the x minus 3 power equals 25 to the 4x minus 7 power. I'm going to do a prime factoring for 625, which is 5 to the 4th. Put it in a parentheses because it already has an exponent. Do a prime factoring for 25, which is 5 squared. Put it in a parentheses because it already has an exponent. Clear the parentheses on the left-hand side going 4 times x and 4 times minus 3 and get 5 to the 4x minus 12. Clear the parentheses on the right-hand side by going 2 times 4x and getting 8x and 2 times minus 7 and getting minus 14. Almost made a mistake. Drop the 5, set the exponents of 4x minus 12 equal to the exponent of 8x minus 14. Do the algebra to solve. For x, I'm going to minus 8x and get minus 4x minus 12 equals to minus 14. Add 12 to both sides and get minus 4x equals to minus 2. Divide by minus 4, getting an ugly fraction answer, or at least a fraction answer, of positive 1/2. And I'm going to check. So for 39, just because I got a fraction answer, I'm going to check. The original problem is 625 to the x minus 3 equals 25 to the 4x minus 7. I'm going to see if 625 to the 1/2 minus 3 power equals 25 to the 4 times 1/2 minus 7 power. And again, if I'm checking, I'm using technology. So left-hand side, 625 exponent fraction 1/2 minus 3. The left-hand side, let me SD that. I'm not going to write that number down. Oh, that's too ugly too. That's scientific notation. That's worse. So this is 1 over 9765625. Let me do the right-hand side. 25 exponent 4 times fraction 1/2 minus 7. And I get exactly that same number, 1 over 97,65625. So no, my answer is right. So finish up this doing 37 and 41. That will be all the odds in the section. So just get those pushed out of the way, and that will be good for this section. We just have one section left. It's word problems, but it's not a particularly hard word problem section.